Hallo und herzlich willkommen zu Data Science mit Milch und Zucker. Mein Name ist René Brunner und ich freue mich, dich in die faszinierende Welt rund um Data Science, Datenanalyse und künstliche Intelligenz zu entführen. In jeder Episode werde ich mit renommierten Experten sprechen und dir praktische Anwendungsfälle sowie die neuesten Entwicklungen aus der Welt der Daten näher bringen. Und das alles in Bezug auf den deutschsprachigen Raum. Also schnapp dir deine Tasse Kaffee, Tee oder was immer du auch bevorzugst und lass uns gemeinsam in die Welt der Daten eintauchen. Mit einer Prise Milch und Zucker. Hallo und herzlich willkommen zur nächsten Episode des Podcasts Data Science mit Milch und Zucker. We talk again today in English. We have our guest, Dr. Carlotta Schatten. She is Engineering Manager, Data Science at AutoScout24. I'm very happy that she's joining the podcast today. We'll talk about from proof of concept to product, direction of ML ops, also how teams can integrate, data scientists can integrate in the company. But now, welcome, and I'm happy that you're here, Carlotta.
Thanks, René, for having me, for inviting me. I'm really excited to talk about how to bring machine learning to production and the challenges that I have encountered in my career. Quickly about me, I have a PhD in machine learning, transitioned then to the industry, and by now I have 10 years of experience in this great adventure that is machine learning and machine learning as a product. So first of all, I wanted to mention a bit how data scientist works within companies. I think it's always an evolving topic, and probably there are many different setups. But I think the main two that are arising are centralized team where data science is assured as used as a shared service across different departments, or also data science embedded in cross-functional teams where they need to integrate to coordinate with different professionals focused on the development of one specific product. In all this setup, cross-functional collaboration is needed, and therefore it's important to understand who can give you specific information and how the different functions collaborate together.
So you have a team, let's say we're already deeply in there. We have a team, it's centralized, and all data scientists, they work in a company, let's say, or maybe more, but in general, we see one central data science team for the company. And then this team needs cross-functional to connect to different persons in the company.
Yes, in the case of a centralized team, you have a centralized prioritization system. You gather at the beginning of the quarter, you gather different requests. You prioritize basically based on where do you believe there is the highest data science impact. And then based from there, you gather all the different, you go into the development phase, trying to gather the functional and technical requirements. So in this, and in order to do that, you already see that we have the first cross-functional touch point, namely with the product managers and the engineering manager of the requesting team. The product manager has the goal to provide the strategic guidance for the development of the product. So it's basically trying to convey what are the business needs in the design. And whereas the engineering manager or the engineering developer aim at basically implementing the software, the architecture, which is needed then to integrate the machine learning model into production. And I think these two functions are the one that are maybe the farthest away. Usually they have a less understanding of the data. Of course, there has been a lot of push to transition to data-driven mindset, but it has anyway, it's people that have less background, data background.
And the product manager, of course, then he's out. He has not so many data science experiences in general. And you have different product manager. Maybe one is from marketing department, one is from controlling, one finance, manufacturing, and so on. And then you have the engineering manager. But if they are like ML ops engineers, then it's a central team, or it's also belonging to that different departments. Probably it's also a centralized team.
In the case of the centralized team, usually data scientists are full stack data scientists, so they aim at developing the product really from the problem formalization up to the productionalization and maintenance in production. Yeah, it can also happen that you have a centralized team with a distinction in career, where you have the machine learning engineer, which is more focused on the productionalization part, and the data scientist more on the model development side. Yeah, so this is basically, I think, the absolute minimum. Then I've seen other setup where you have also the other data function collaborating closer together, the data engineers trying to deliver the data, and the data analyst providing more business insights and storytelling, or maybe also dashboarding for monitoring of the machine learning model in production, and more key performance indicator performances, so related to more to the business metrics that usually the company tries to track to quantify what's the impact of the developed product.
All right, then we have more like a business analyst. It's one function to the business. There's a data scientist developing the machine learning model, let's say, doing the analysis, and then we have the data engineer helping to get the data, to transform the data, maybe also to deploy the model then. Sounds good. And if you now see that we get this new model, now we have the team. How is it going then? If you have a proof of concept, or now the business product manager comes with a new idea, and you rate it as the top idea, or the highest business impact, highest value. How is then the process to become a product?
So there are different phases that now are established. So you have, first of all, the problem formalization. Then what I call proof of concept is some sort of prototyping of the solution with an offline evaluation. This is the phase that we are mostly get trained the most when we start to learn a data science. Then there is the productionalization phase, where you aim at integrating the model in a larger system and try to test it. So in some cases, you will need to run an A/B test, so comparing your model with the previous version, which will be necessary to assess what's the impact on the business metrics. And then you will end up with a maintenance phase, where you basically are using the model in production, but still need to keep an eye on how is it going, basically, while you are maybe working on another iteration or another product. So these are, I think, the four main phases, and each of this phase comes with the cross-functional work and collaboration with different functions, and also some challenges. So I think the main one is the problem formalization. That's the part where you need basically to translate the business problem into a machine learning one. Their collaboration is with the product is fundamental, and as I mentioned, it might be the person who knows less about the the engineering side or the data side. So it's really crucial to establish quickly a way to communicate that it's understandable for the product manager, and try to derive what I call the functional and technical requirements. Functional requirements means what is the product doing, what are the goals that I want to achieve, or sub goals that I want to achieve, and then also technical requirements if it needs to be integrated in a larger system. For instance, for recommenders or for search, you have requirements on how quickly the prediction needs to be delivered. So that's like one part where I would always recommend to go into more seeing it a bit as a contract, where you go over the different needs that there are and try to identify what is the simplest way, which is called the minimum viable product. What is the simplest thing that you can implement to achieve this goal? Or maybe in some cases you will have to define a subset that you want to focus on in a first iteration. Because also for data science, especially because we work on experiments, we are not sure about the success maybe when we start. So it's important to fail fast, similarly as engineers do. And
is this a big challenge? Because I heard often that maybe the customers or end customer from data science perspective, they always expect perfect results, or that they're not happy with the quality, that you also have to define, is it then like functional requirements to say, okay, we cannot deliver 100% accuracy, we maybe only have 95. What will you do?
Yeah, that's a common challenge. Like in most of the cases, we speak about machine learning model error, and machine learning model error relates but is not equal as the key performance indicator. So we need to track both the metrics and make sure that if we speak about some machine learning model error, that the other side is understanding what does it mean, and then also trying to define what's the impact of machine learning. So implementing very simple baseline, showing that this is not possible, it cannot be solved by simple statistics. So if you're working with forecasting, you need to show that moving average is not gonna give you any competitive advantage. And spending some extra time finding an agreement on this will save you a lot of time later.
And is it also about explainability, that you say now you manage this, okay, you say moving average or this won't give you some benefit or some advantage, and now let's say you find that deep learning is giving you an advantage, but then the business side, they also need to understand, or let's say they need to trust the algorithm, because they cannot explain maybe linear regression. They can understand, okay, like this, it's working. But if you say now there's an AI, you don't know how it's working. It's a black box. How they react to it all? They say, okay, it doesn't matter so much.
I think I've seen different ways. What I believe works best, as I mentioned, you start with the pure baseline. If it's statistics, it's good, and then you basically aim at showing them, like, look, maybe you use the traditional machine learning more. Like could be a random forest, XGBoost as a reference, and then you can show, okay, look, this is the error. You can see what are the most important indicators for the model to generate a reliable prediction, and then you go into deep learning basically, and show in the agreed error metrics that there is a positive impact. So building up the trust with the stakeholders, using as a comparison things that they are maybe easier for them to grasp and to understand, and then show the added value.
and to dive in. All right, that sounds cool. And what are the other challenges of the 4 phases which you mentioned? Now we have been at the first phase of the product formalization or problem formalization. Do you also have some other challenges in other phases?
Yeah, so I think I don't want to spend much time in the proof of concept phase. I think here we can only study the books and get familiar with the model development. With model development, I think one thing, but that I would like to mention is really like data quality and investigating the data before jumping into building models. That's, I think, the biggest pitfall and something that generated a lot of pain for me and my team members, starting to design a model and then understanding after 1 month that maybe the data was not good enough for the task. So invest some time there. It's only, and then also the company will be grateful because data is quite valuable, and if you can basically provide feedback and advice on improved ways to collect the data, usually you're also generating company value, and so that's.
Yeah, but do the people understand that you're generating a company value? Because first, if you need time to invest in the data quality to improve it, and normally people, they come and they always have fast deadlines and they want it yesterday, and then you have to explain, oh, I need maybe some weeks or days to get the data quality. Then you come up here, your data is not good, or this is not good, and then maybe they also get impatient and want to accelerate. So how first you also need to convince them that it's important, because I would imagine that not everybody understands it.
There has been quite some changes in the area. First of all, the advice is to discover it rather quickly, and usually there are in the companies like more in the data analytics side. It's called now data governance. People spend time in assessing the quality of the data. Especially if this data is the key performance indicator that I was speaking of, and most of the time, this key performance indicator also represent the most important data sources for data science models. So there is currently quite some attention to the topic.
That's cool. And do you have some examples for data quality measurement, or you have like your own tool, just monitoring, and if there are outliers or if there's a data drift, then you get alerts, or if the schema is not matching, or?
I think like a good subset of the activities that you mentioned. I think there are nowadays libraries that support automatic data quality, and overall it's important to have them in place. I think. Great expectation, deep check, and I think there are like way more that one can could investigate. And I think what's most famous and most challenging for machine learning specifically is the so-called data drift, where basically the distribution of the data that you used for training is different than the distributions that the model is currently using to generate the prediction. So this is something that nowadays can be automated and verified with some of the libraries that I mentioned before. So.
But then you also need, I think it's also let's say twofold or two sides. One is that you need the tools, you need to install them. But then probably you also need some domain expert or some data owner who is responsible for the data and takes care if the tool is telling here's an anomaly or here's a data drift, and he has to check, dive in, what is it? And also from his normal business, or he has to dedicate some time to keep the quality of the data and then to check if there's an error and also dedicate energy or to it?
Yeah, I think this comes basically to what would be like in my opinion, the great advantage or like the great lesson learned for the other two phases, which are basically the productionization and the maintenance. That it's the more you can automate, the better. And I think specifically for this case that you mentioned, having some alerting in place is definitely something that you need. And if it's a data collection problem, for sure you need the main expert or like the engineer of the team to fix the tracking issue. The data analyst maybe investigating if there were specific problems there, but in case of a data drift, maybe being able to automatically retrain the model. That's something where in some cases you don't even have to worry about. So you monitor the performance of the model over time. You see that there is a degradation slowly or quickly, and then you, based on that, you decide when to trigger a retraining, or maybe you need to do another hyperparameter tuning round. If you notice that you know that you will have to check the model again.
Okay, so we have a monitoring system. It detects the data drift or something, and then it triggers automatically the model training process, and then the data scientist can come, compare the current model with the old model, and then how is it? What do you think how is this current state? The model, the data scientist will deploy the model, or I think it can be already fully automized. That also there's a data drift, model is trained, and then some algorithm is deciding, okay, new model is better, deploy directly in production. Or do you think there's still a step where human needs to interact?
I mean, I think by now there are the tools to fully automate the process end to end. It's gonna be a bit challenging in some cases to understand automatically if there was a degradation of the model that needs, for instance, a hyperparameter tuning, and then the moment you do a hyperparameter tuning, it might be challenging to assess exactly if the new model is actually better than the old one. Maybe you also need, if the model degradation was triggered by data quality issues, then it becomes, you need a golden data set. So it might become quite challenging to automate it really and completely end to end. But I think a basic degree of like some automation is needed, especially in monitoring, alerting, and probably the main phases for simple retraining. That's something that definitely can help, and the rest comes with a bit of challenges. So you will you will need a lot of resources to put the full system in place in a reliable way.
Yeah, it's, now we made a cool round from the data science cross team functionality, so the 4 phases, to data quality, which is a huge or a big challenge. I also think it will be really important in the future, the garbage in, garbage out principle.
That always, garbage in, garbage out is our mantra.
Yes, but it's easy to understand, and it's also logical. So I don't know why people before didn't focus on it. And then also the completely full automized end-to-end pipeline, which is also will be cool in the future. And I think data scientists, they don't need to worry that they don't have to work anymore. There will be many jobs for data scientists. But yeah, and now then we come to the end. I would like to ask you some tips or advices for data science beginners or for companies.
Like going over a bit what we discussed again, I think like first of all, when you will join in a new company, to ask what are the different functions involved in the you will collaborate with, trying to understand who does what, because you will know what's in the book, but then in the reality it could vary a lot from company to company. And then, especially in the first design phase, spend extra time to understand exactly what product wants, and keeping an extra eye on data when starting the development phase, and then finally try to automate specifically monitoring and alerting in the maintenance and productionization phase, so that you are able to intervene if something goes wrong.
And not only deploy and run away, but stay to it and monitor and look what your model is doing. So
and then also like don't get discouraged if your experiment is not successful. Usually 2 or 3 rounds are needed, so it's all good.
Perfect. It's like in this YouTube videos where the people make stunts. Also my son last time he told, but he is never falling and he thinks it's perfect. So also you only see the perfect slides if you go to conferences. Yes, it looks like it works always perfect, but it doesn't.
And like when you have to debug experiments, a good monitoring will really give you the extra insights that you need to understand where to go next.
All right. Sounds like very cool advices. I think everybody will help also for data science seniors to remember the advices, and maybe it's also new. So thanks, Carlotta, for joining the podcast today. It was a great pleasure to have you in our podcast.
Thank you.
Das war's für heute in Data Science mit Milch und Zucker. Ich hoffe, du hattest eine lehrreiche und unterhaltsame Zeit mit uns. Vergiss nicht, den Podcast zu abonnieren, um die zukünftigen Folgen nicht zu verpassen. Teile ihn auch gerne mit deinen Freunden und Kollegen, die sich für Data Science interessieren. Wenn du Fragen hast oder dich in einem bestimmten Thema brennend interessierst, dann schreib mir einfach gerne eine Nachricht. Du findest mich auf LinkedIn, wo ich dich auch immer über neue spannende Themen rund ums Thema auf dem Laufenden halte. Zum Beispiel mit meinem neuen Buch Python Schritt für Schritt programmieren lernen. Außerdem findest du meine erfolgreichen Data Science Kurse auf Udemy. Du siehst, wir wissen, was wir tun, wenn wir wieder eine spannende Folge unseres Podcasts veröffentlichen. Vielen Dank für deine Zeit und dass du Teil unserer wachsenden Community bist. Bis zur nächsten Episode von Data Science mit Milch und Zucker.